Let's solve the number of islands algorithm so that you get sharp for coding interviews. I'm Rafael Del Nero, a Java champion, and I help you stand out as a developer, get your dream job, and be well paid. Now let's explore the fundamentals of the number of islands algorithm and implement the code. Okay, so let's explore the fundamentals from the number of islands algorithm. So first of all, we're going to be solving this algorithm with the depth first search algorithm. And we're going to be exploring a little bit of the graph data structure. So what is exactly the number of islands algorithm? So the number of islands algorithm is a 2D grid map of ones, which represents the land, and zeros, which represents water. And then we're going to count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. And you may assume all four edges of the grid are surrounded by water. To understand clearly how can we count the number of islands, let's check some examples. On this one, we can see that we have one island here because those are connected, and that's it. We have only one island. As you can see, the output is 1. And in this case, we have 3 islands. Why? Because we have 1, 1 here, and 1, 1 here, and we have 0 on the right and 0 on the bottom. And down here we have also 0. And remember that this is a separate island because we have water on the left, on the right, up, and down. If we have another island on the diagonal, this means this island is another island. So this is an important detail of this algorithm. And this is a third island. So why is the third island? It's because it's surrounded by water on the left and up here. Therefore, the output should be 3. And the real world relevance of this algorithm is to use in scenarios such as network analysis. So in this scenario, you might need to find connected components within a network. And that's enough to get started. So let's go to the fun part. Let's go to the code. Okay, so this is the code. As you can see, we are returning an integer and we are receiving a 2-dimensional array named as grid. And let's see here how this data would be sent to this method. So the data would be sent like that. And this is the simple case where we have 3 islands. Okay, so let's get started in our algorithm. It's important when you're doing a code challenge interview to always ask your interviewer so that you know what are the edge case scenarios of your algorithm. In that case, you have to ask if the parameter could be sent as null. If that's the case, you ask if the grid is null. You make a basic validation to cover those edge case scenarios. So here we are checking if the grid is null or if the grid length is 0. Because if that's the case, we can return 0 islands right away. And here we're going to have a variable to count the number of islands. And now let's iterate over the bidimensional array. And to be more clear here, I will use the name of row. So our row will start with 0, then while row is lower than grid.length, then row plus plus. Then we're going to create another for looping for the columns. And just to make it clear, on this looping, what we are doing, we are going through the rows. So we have 4 rows in this case. Now we're going to iterate over the columns. It will start with 0, while column is lower than grid row.length. So here basically we're going to get the columns length of each row, and then we're going to increment the column. All right, now we have access to all elements of our grid. And now we want to check if the current grid position, the grid on the row and column, is equals to 1. Then we want to check how deep the island will go in every direction. And an effective algorithm to solve that is the depth first search algorithm, also known as DFS. So let's create here DFS. We're going to send the grid, the row and the column. Let's create this method. We can use this shortcut on IntelliJ to create the method automatically. Okay. So now let's prepare our base condition for our recursion methods. So we're gonna validate first the row, and then we're gonna check if the row is invalid. And if that's true, we return. We basically break the recursion. Now let's validate the column. So if the column index is lower than 0, if it's negative, it's invalid. And if the column is greater or equals than the total length of the row, and this is this length, so we have 5. On this input test case, it would be 5. So basically, we don't want the column to be 5 or more than that, because as we know, arrays in Java starts from 0. In the case of this input data, it would be 0, 1, 2, 3, and 4 as index. So basically, we want to make sure that the index is correct. And if the column is invalid, then we also break our recursion. And the last validation is if it's water. So we're gonna get the grid, the row, and the column. If it's equals to 0, it means that it's water. And in this condition, we also want to break the recursion. And in the case we pass in all of those conditions, we want to change the grid current position from land to water. How can we do that? We can do that by assigning 0 to the current position of the bidimensional array. And then we're going to start using recursion. So first, we're going to explore down. To do that, we're gonna pass the grid, row +1, and column. Now let's explore up, and to go up, we do row -1, because let's see here again. So if we are in the row 1 and column 1, if we do row +1, we would be going to this element. And let's suppose we are on this element. If we want to go up, we would have to do row -1. And then in that case, we would go here. Let's continue. So in this case, we're going to explore right. And to go left, we do -1. How would that work? Let's suppose we are here on column 0, 1, 2, and row 0. And if we want to go right, if we add 1 to the column, it would be here. And if we want to go left, we have to subtract the column by 1, and then we would go to that position. Okay, so now here, whenever we find the land, we're gonna explore all the directions where we also have land. So we're gonna do that vertically and horizontally. We're gonna be able to fully explore the land, the island, and once we explore the island, we're gonna set 0 to this island, which means that we're gonna visit every element of the island exactly once. And then once we explore the island completely using the strategy, then we're gonna increment the island's count. And then we're gonna return the island's count. So this is pretty much the algorithm. And let's now debug this algorithm to see it working in practice. Okay, so let's debug this simple case. So here we check if the grid is null, it's not, and we check if the length is equals to 0, it's also false. In that case, we have a valid grid. Here we start the island's count variable, and in this line of code, we are starting the row, and as we talked before, we have 4 rows, and we're gonna iterate through the rows, and here we're gonna iterate through the columns. And in Java, to reference the column's length, we need to first refer the row, and then we can retrieve the length of the columns. In the case of this input, we have 4 rows and 5 columns, right? So that's why we have 5 here. So here we're gonna check if the current element is a piece of land. So if it's equals to 1, it means that it's a piece of an island. And then let's go to the depth first search algorithm, also known as DFS. And here we're going to check if the row is negative. In this case, it's not. And we're also going to check if the row is greater or equals to the length. So basically, we want to make sure that the index for the row is valid, because if it's 4 or more than that, we would have an array out of bounds exception, because as we know, arrays in Java starts from 0. So here would be 0, 0, 0, 1, 0, 2, 0, 3, and 0, 4. So that's the maximum. So in the case of the rows, this would be 0, 0, 1, 0, 2, 0, and 3, 0. This means that we don't have the index 4 for the rows. So that's why we are doing that. In this case, the row is okay, it's valid. And then we check if the column is invalid as well. Here we check if we have a negative number for the column. And on the second check, we make sure that the column has a valid index. In that case, the maximal index for the column is 4. Why? Because if we check here, it's 0, 0, 0, 1, 0, 2, 0, 3, and 0, 4. In this case, the column is valid, so we want to break our recursion. And here we check if the current element of the grid is water. How can we do that? By checking if it's equals to 0. In that case, it's also false. Why? Because we are currently here. And then to make sure that we are not returning to this element, we are assigning 0 to this row and column. This means that this will become 0. So we can even see here. So it's even easier to check here. So as you can see, it changed from 1 to 0. And then we're going to explore down. So here on the row 1, we still have land. So let's invoke our DFS recursion method. So the validation will pass. And you're going to notice that this number 1 will be changed to number 0. We're going to do the recursion again. And you can see the recursion methods here. So when we use recursion, we use the data structure of stack. So it means that one method will be stacked on the top of the other method. So remember, when you stack plates, it's the logic of last in, first out, which means that the last plate you put on the top of the stack is the first to be removed. So it's the same logic here when we are using recursion. So remember that the methods will be stacked, one on the top of the other. So we're going to invoke again this method, and the base condition will be met. Why? Because when we test this element, we're going to notice that this is water. So let's see what happens then. Yeah, this condition will be true. It's water. So now you could notice that the methods are being removed from the stack. Why? Because the base condition of the recursion was met. So now we're going to explore up. In that case, it's also water. So we are going back here to the first one, and then this base condition will be also met. The method will be removed from the stack. And then here, we're going to explore the right side. So in this case, we're going to explore this element, which is 1. All conditions will be met. We'll pass here. And you can notice that we're going to change this element to 0. And here from row 1, we're going to check this element. So we're going to go to row index 2 and column 1. So this is water. We're gonna break our base condition from our recursion. One method was removed from the stack, and now we are at the row index 1. And if we go -1, it's gonna go to the first row, and on column 1. In this case, it's also land. So our conditions will be valid, and we're gonna set this land as 0. And now there isn't any other land down, up, right, or left. This means that all those methods will be removed from the stack. So let's see that happening. It's water, one method removed. It's water. It's water. Now we have 3 methods on the stack. It's negative, so column 1 and row 0, it's water. So another method will be removed from the stack, and the last one was removed from the stack. So now let's continue iterating over the grid until we find another island. We don't have any island here. Let's keep going. Row 1 now. So we are here. We have only water here. Why? Because we changed all of those elements to 0. Therefore, there isn't any island here anymore. Let's continue. Row 2. So we are here now. So here we have another island. Why? Because we don't have one here, one here, one here, or one here. So this is a separate island. Let's continue. So on row 2 and column 2, we have an island. So let's do the depth first search algorithm in this island. All those are valid. And then other remaining base conditions will be met, because as you can see here, we don't have an island here, or here, or here, or here. So we can go. So all of those methods are being removed from the stack. Yeah, so we found one more island. Let's increase our counter. And now we're gonna find an island only here on line index 3 and column index 3 as well. So let's see here, row 3. Yeah, so on this position, we have an island. So let's go to the DFS again. In this case, we don't have land here, but we have land on the right. So let's check how that works. So since we visited this piece of land, we're gonna set this one as 0 so that we don't go back to check this one again. So down we have nothing. So let's see. So here the row is 4, which means that the row is invalid. So this condition will be true. Here we have water. So this condition will be true. And on the right, we have land. So we're gonna set this last element as 0. Now the methods will be removed from the stack. So let's see here. We can see the methods here. All base conditions will be met. Yeah, now the last method will be removed from the stack. And that's pretty much it for this data input. Now, if we test this grid 1 input, we have an empty array. Let's see what happens. The grid's not null, but the length is 0. Therefore, we return 0. And for grid 2, let's check here. We have only one island. We have the output of 1. Let's debug this complex configuration now. We're going to start iterating over our bidimensional array. So the first element, as you can see, is 1. So all of them will be valid. Now we're going to go to the second line, but it's water. Therefore, this method will be removed from the stack, as you can see here. Now we're going to explore up, but the row will be negative. And now we go back to the main method invocation, which is chill number 0. But now we're going to explore right. And we have water here, you can notice that. So we're going to set this element as 0. We're going to explore down. We also have land here. So we're going to change this element to 0. And now all base conditions will be met. And notice that this is the main method and is the last one to be removed from the stack. So it's last in, first out. So we're going to see that the 33 method will be removed from the stack now. Yeah, okay, so let's continue our iteration until we find the next island. In this case, it's going to be here. So let's continue. So we are here in line 1 and column 4, which is exactly here. Let's keep going. So if we explore down, we're going to find a piece of land here. And we're going to set this as 0. And the first method is still at line 37. Let's keep going. The second method is now at line 38. And here, row number 2, it's going to go back to row index number 1. And column index number 4. It's water. So in that case, column plus 1 will make the column index invalid. Why? Because the column is out of bounds of the array. The base condition will be met. This method will be removed from the stack. And here on line 2, going to the left, there is also a piece of land. Let's keep going. And we're going to also change this piece of land to water, so we don't come back to it. And we are down here now. We're going to change that to 0. When we go up here, it's going to be water. When we go down here, there is more land. So let's continue. And we transformed this piece of land to water now. Now, if we try to go down again, the row will be invalid. So this condition will be true. Then we're going to break the base condition. And notice that every time we are using recursion, in the first method we invoke, whenever this first method is at line 40, the recursion will be closer to be finished. So let's continue. So we are here on row 4 and column 3. And in this case, we're going to find water. And here on row 4 and column 3, we're going to also find water. And here on the left, we're going to find the land. All of those conditions will be valid. And we're going to set this element as 0. So in this case here, the row is invalid and we are on row 4 and column 2. In this case, up here, we have piece of land. So we're going to transform this piece of land to water, and then we're going to meet all the base conditions. You're going to see all the stacked methods being removed from the stack. So let's go. And you can see that the first method is still at line 37. Let's continue. And we already found the last island. And we changed them to 0 already. And as you can see, the number of islands in this case is 3. If you watch the whole video, it's because you want to pass on interviews, you want the best for your developer career. And as a reward, I will give you my Challenger Developer Guidebook, and you can download this book on the comments down here, and it's totally free. You can get this book and apply those principles on your developer career so that you grow faster and you become an excellent, respected software engineer. And that's pretty much it, Challenger. I hope you enjoyed this video, and I'll see you in the next one.